This recording is for Primary Math 2. We're working in the class recording on week 2, and this week we are assigned to do the workbook exercises 8 through 14, intensive practice pages 14 to 17, and we have still not started in the challenging word problems book yet. Usually I don't. This time I do have a suggestion about an order of how you complete these, and that is I suggest you do the workbook first for the exercises 8 and 9, and then you really need to do intensive practice 14 to 17 before you do exercises 10 through 14. Generally speaking, I don't have an opinion, but this time it particularly works out to do better that way. So let's start talking about the workbook, exercises 8 and 9. In exercise 8, there are two huge concepts that we present, and we just have to make sure that our children really understand them, and that is the first thing they do is tell you all the ways you can add and subtract the same three numbers and make it work. 8 plus 2 or 2 plus 8, same thing. When you're subtracting 10 minus 2, you get 8. 10 minus 8 is 2. The idea, of course, is to understand that if you have a block of 2 and a block of 8, that you end up with a total block of 10. And if you combine 2 and 8, or if you do 8 and 2, if you take away the 2, what you have left is 8. If you take away the 8, what you have left is 2. We need to really have a good understanding that all of those mean the same thing. And we're recognizing number pairs so we can do subtraction by thinking about addition and just kind of getting those in our head because they're really the same thing. It's almost like saying they're using the same different phrasing with the same language, the same conversation. We have to make sure we understand all of those are the same. And then another very important concept for later on. I see this a lot in my upper math classes. Students struggle with this. 12 minus 4 means 4 less than 12. Now, of course, an upper math student doesn't struggle with it until you say 4 less than x, which of course we're not doing today, but that's the application. When you see that, they need to be able to realize that that's x minus 4. Way too many times people put 4 minus x instead. And so the idea is it is not 4 minus x, and that concept is birthed in this lesson. When we say 4 less than 12 means start with 12 and go 4 less than that. Subtract 4 from 12. So all of that is found in exercise 8. And exercise 9. I actually want to start talking about this page with an analogy that I like to use about math, and that is one that I talk about children when they're crawling and walking. As we all know, our little ones start off crawling and they get really fast at crawling. They get across the floor in record time, and then they one day look around and realize that people are walking on 2 feet, and they decide they want to be one of those people, and their feet actually have value besides the knees that crawl on, and so they stand up and they start to toddle across the room, and they take 2 steps and they fall down, and they take 2 steps and they fall down, and it is much slower going to walk than to crawl. But it doesn't take long before crawling goes completely to the wayside and walking is a much faster way to get across the room. But there is that transition time in which really crawling is faster, but walking is preferred. And so there is that analogy in the lives of our children is something that I use a lot to describe mathematics. The way, in my strong opinion, we all have opinions and we all have strong ones. This is one of my strong ones. In my strong opinion, we teach children how to crawl mathematically in America, and we never go any further and teach them to walk. So as an adult, if you asked me what is 27 minus 18, I would have mentally pictured 27 minus 18, and I would have in my mind tried to borrow 1 and carry this 7 and end up with 9 and 0, or just the answer being 9. I would have mentally tried to carry that picture and do it because that's what I was taught. In my opinion, that's the crawling way to do subtraction, and there's a walking way to do subtraction. To walk this problem through, I would take 27 and I would subtract 20 and put 2 back because that's what 18 is. And that would take me down to 7, add 2 is 9, and that's much faster. But doing 2 operations instead of 1 feels slower. So right now, even in Singapore Math, we're going to teach our kids to crawl a little bit, and that's okay. It's a good thing. We teach all of our children to crawl before we teach them to walk. What I want to warn you of, or maybe encourage you with, that it will come a time when we'll work on another way to do this, but this is a good way to start understanding what's going on. So, in the intensive practice book on page 14 and 15, we're going to start by learning how to add and subtract, and they call it without renaming. We won't have to borrow or carry or do anything like that. We just strictly have to add things together, and they suggest that we do it by starting with the ones column, and I drew a picture. 321 means 3 hundreds, 2 tens, and 1 1. That's what we've been working to get them to understand, so let's not lose that understanding of what's going on. We have 137. I hope that in their mind, they don't have to draw it, but I hope in their mind they understand that that means 100, 3 tens, and 7 ones, and if I combine those ones together, I have 8 ones. And it doesn't take a lot of drawing and conversation to realize that the 2 tens and the 3 tens are going to combine in my tens place. And when I get that, I'll have 5 tens. And of course, in the ones column, or the hundreds column, I have 3 hundreds and 1 more hundred, which is going to combine to be 4 hundreds. And so the solution to this problem is 400, 5 tens, 8 ones, or 458. On the other side of the page, we do some subtraction without renaming. Subtraction's even easier mentally because you think of having 6 hundreds, 7 tens, and 9 ones. If I erase, maybe I should just can't cross out so we don't lose them. If I erase 2 ones, starting with 9 ones, and get rid of 2 of them, I'm going to have 7 ones left. If I have 7 tens and I want to get rid of 3 of them, then obviously I have 4 tens left, and it doesn't take much to see that if I have 6 hundreds and I get rid of 1 of them, then I'm going to have 5 hundreds left, and so 547 is the answer. Again, that's without renaming. I'm just simply combining or removing ones and tens and hundreds, but it gets a little more difficult. Moving on to page 16, where the first problem is 375, add 137. It could look something like this. And the instructions for this lesson are to start with the ones column. We won't always do that with Singapore Math, but when your children see 5 and 7, hopefully they think in terms of 5 and 5 make 10. And so if I ignored those 10 and added another 10 bar to my list, then what I have left are the 2 in the ones column. And I have that extra 10 that I can now consider. When I combine my tens, I have 7 and 3. That makes a 10 all by itself. And so I know that 10 tens makes 100. So instead of what I had before, I have another 100, but that 1 10 is still there. So I'll count that one as a 110. And then when I want to look at my hundreds column, I have the 300s and the 100. And I didn't write down over here the fact that I had that other 100 from the 10 tens combining. So here's that other 100. And of course, all together, that gives me 500. So when I add these two numbers together, I have 512. We can understand what it is visually. We can do it, just the algorithm, the step-by-step method of doing it on this page. We can incorporate the fact that we know that 5 and 5 make 10 and that this is 2 above that, and think about it mathematically that way as well. But that is just the beginnings of understanding how to solve a problem with adding and renaming. Let's talk about subtraction. I think it's very important, especially with subtraction, that they not just do a bunch of steps and solve a problem. That's an algorithm, is just a step-by-step way. If we just tell them that you can't do 1 minus 9, so mark that out, put a 1 and put 11 here, or put a 1 there, and now you have 11, poof, it becomes 11. That doesn't really tell them what they're doing. I do think with subtraction, even at this stage, it's important to have a drawing and understand what's going on here. And so the idea of course, is that if I have 1 and I'm trying to subtract 9, that I can't do that. And so the plan for this is to take a 10 and break it down into 10 blocks instead of one big block of 10, break it down into 10 blocks like that. And if I subtract 9 of them, and all of those go away, our students know that we have 1 left from this 10. If you subtract 1, there's 1 left, and then there's another one there, so that's 2. Then the problem is I used to have 2 10s, now I only have 1 10, and I'm supposed to subtract 4 10s. So what do you suppose we're going to do with that? If you guessed, of course, we'll borrow it from the 100. That's exactly right. That 100 is now going to be 10 blocks, and I'm going to subtract 4 blocks. Now, one thing that is part of the Singapore math idea is that I can take 4 away from 10 really easily. I know that it leaves 6. We've done those number bonds quite a bit already, and I know that there's 6 from the 10 or from the 100, and there's 1 more from there. So I know that when I subtract my 4 10s, I'm going to have 7 10s. And by the way, I know that I now only have 4 hundreds. I ended up with 11 10s. That's what that means when we carry that over there. And now I have 4 hundreds, and I want to get rid of 100. Well, it turns out that that's easy enough, of course. I don't have to nothing to borrow anything from, but from these 400s, if I get rid of one of them, I'll have 300s left. And so that is the algorithm and the steps, helping them learn the steps. It shows it right there. It tells you what to do. I think it'd be a good idea if you have your blocks, your hundreds of blocks, and see how to do that, or just make squares with paper. You don't have to have anything fancy. But the idea is that this is, you have blocks, and a tens is made up of 10 ones, and this is made up of 10 tens. Of course, mine are just sketches. They're not nice and lovely, but that's the idea that we want our students to have when they're adding and subtracting and they're doing the renaming part of it. And now at the end of the intensive practice, this time we're going to go back and talk about the rest of the exercises in the workbook. We've already done 8 and 9, so we'll start with exercise 10. These are word problems. And normally I don't do the word problems in the workbook, but today, because we're early in the year and I want to make sure that you know how to talk about them, how to show them, things like that, we can do that. They're very intuitive at this stage. They're one-step problems, not too much to do, but it doesn't hurt to begin with some study skills and some ways to consider and to help them mentally to understand what's going on. In number 1, Mrs. Chen made 45 buns. So we do a lot of what's called bar modeling, making a bar and using that to model what's going on. And so if this bar represents the 45 buns that Mrs. Chen sold or made, and then what we're told is she sells 31 of them. So those 31 are altogether gone. And the question we want to know is, if she made 45 and sold 31, how many are left? Well, this goes back to exercise 8. We have a problem. Something plus 31 is equal to 45, and we also learned that in that exercise that we could say 45 minus 31 is that same number. And so we can think about this either way. This is a subtraction problem. It's subtraction without renaming, so that number is going to be 14. We can see it either way. If I have 3 10s and I want to have 4 10s, I need to add 1 10. If I have 1 1 and I need to have 5 1s, I need to combine that with 4 1s. Or you could do subtraction. 4 10s minus 3 10s, 5 1s minus 1 1. That is 14. And so she had 14 buns left. By drawing a picture, you see really clearly that the ones that she has left combined with the ones that she sold are going to give us that total of 45 buns. A picture really helps to solidify the idea in our students' minds. Number 2, we have some red apples and green apples. We could even color code it. The green apples that Jill purchased, number 24, and the red apples that Jill purchased are 37. So clearly there's more red apples. I would make my red apple bar longer than my green apple, but notice I'm not counting and trying to get exactly 24 units or exactly 37 units. I'm just making a representation, and the question we're being asked here is how many more red apples are there than green apples? Well, up to the point that they're even, they both have 24. But 37 is more than 24 by some number. So into our minds should spring a problem. 24 plus the number I'm looking for is 37. Or maybe they think 37 minus 24 is that number I'm looking for. How does your student want to do it? Decide how many more ones you need and more tens you need? That would be 13. Do a subtraction problem, take away some tens, take away some ones. Of course, that's 13 as well. So she bought 13 more red apples than green apples. And again, really obviously, the part that's above the green apples added to the green apple number is going to equal the red apple number. And so you see how very concrete way of looking at it helps our students to know what's going on. You don't necessarily have to do these problems with a bar graph, but it would be helpful to see it and to know it for future and to kind of begin to think about problems that way. Number 3 tells us that Ryan is 23 years old. So Ryan's bar is 23 long. The father, it tells us that he, being Ryan, is 24 years younger than the father. Well, that makes sense to us because we know the father is going to be older than Ryan. And what they've told us in the problem this time is the amount that father has more than Ryan is 24. And the question we're being asked, always good to know what you're being asked, is how old is the father? That's what we're trying to find this time. We know that he's 24 more than Ryan. We know that Ryan is 23, so the part that they're equal is 23, and in addition to that, the father has 24 more, and so by looking at that, we know that the number we're looking for is going to be the sum of 23 and 24. That would be 4 tens and 7 ones. The father is 47 years old. The next problem is made concrete by the fact that we have a picture going on, but part A says that Sammy bought a book and a pen, and we're trying to figure out how much money he spent in all. To find out the total number that he spent, you're going to take the price of the book, which we know to be 32, and the price of the pen, which we know to be 2, and combine those, and that'll be the total number he spent. What we're being given are the two little parts. What we want to know is the total that he spent. For part B, we're told that the train set costs how much more than the doll. So if we were to draw a picture of that, the train set is $23. The doll is less than that. The doll is 11. And the question they're trying to find is how much more is the train set than the doll? Well, the doll is 11. How many more do we have to get to the train set? And that would be 12. Again, you could do that by thinking about an addition problem. What do I have to add to get 23? Oops, sorry. Hit the wrong button there. Or what do we have to subtract, or when we subtract 11 from 23, what does that leave left? And either way, of course, the answer is going to be 12. So the train set costs $12 more than the doll. The next question, if David had $86, that's talking about the entire amount he had. He bought a watch and he has how much left? A certain amount of his money is now gone. That would be $15 that is gone, and we're trying to find out how much does he have left. Again, some number and 15 combined to give us 86, or 86 take away that 15 tells us how much money we have, and so the money that he has left is $71 because 71 and 15 combined to give $86. Last problem on that page, Suman had 30. and Suman wanted to buy the book, and how much more does he need? He has 30. His need amount in order to buy the book is 32, and so the question is, how much more does he need? If this part is 30, obviously the amount that he needs is $2. You can make a math equation out of it. You can solve it intuitively. Either way will be just fine. I want to point out to you now some similarities, and often you'll see this in your book. If you look at exercise 11 and 12, and then you look at exercise 13 and 14, you'll notice that they're basically parallel exercises. 11 and 12 are over addition, 13 and 14 are over subtraction. The first thing we talk about is the fact that 5 ones and 3 ones equal 8 ones, and 5 tens and 3 tens are equal to 8 tens. And we even can realize that 5 hundreds and 3 hundreds equal 8 hundreds. And we want to really understand that. I work with friends and neighbors and tutor kids and things like that that go to public school, don't use Singapore math, whatever. And the number of times that I have a student who says 50 plus 30 and they have to add it like this because they don't understand that the fact that they know that 5 plus 3 is 8 means that 50 plus 30 is 80. That's atrocious, right? We need to understand that it's the same thing. 5 tens and 3 tens is 8 tens, also known as 80, just like we know that 5 and 3 is 8. And if you look over in exercise 13, they're going to start subtraction with that same exact concept. And they use 8 ones minus 2 ones is 6 ones, and 8 tens minus 2 tens is 6 tens, and 8 hundreds minus 2 hundreds is 6 hundreds. So when you see the problem 800 minus 200, you can think, oh, I have 8 of those hundreds and I'm subtracting 2 of those hundreds. I'm going to have 6 of those hundreds left over. It helps them to think in terms of place value, and then when you see the word and see the number, you can begin to think of it as 8 hundreds, not as this big number I have to write down and subtract in that way. So in exercise 11 and exercise 13, if you notice, it's exactly the parallel of those. Then the next thing they do is a cross number puzzle. And those are, of course, on page 31, and it's also on page 36. One is addition, one is subtraction. It just gives them more practice. It gives them a different way to write the answer. It gives them a chance to see it. You know, you kind of double check your answers when you have a number that is the same in the across and down column. So those are good things to do. Then they move on to do a puzzle in exercise 12. In exercise 14, I always recommend when you do those problems to solve them all the way and then write your answers in the puzzle. Otherwise, there's this tendency to have students who answer the math based on what they know the answer is in the book because they've figured out the answer to the riddle, and we wouldn't want them to cheat like that. We would certainly want them to be able to do it. So on page 32, certainly solve it and then write the answer. On page 37, you're going to solve it and then draw in the pictures to do that, but they're just doing, it's just practice on addition and subtraction. Then the same kind of a thing on page 33 is more practice. And page 38 is just more practice. We keep practicing and keep practicing. 38 would be a great one to do. Even it's just written side to side on page 38. So we have 437, subtract 132. They don't necessarily have to go to a piece of paper and write it vertically. You can ask them to picture and have an idea in their mind. None of these are renaming. They're doing very basic, simple subtraction. 400s minus 100 leaves you with 300s. If we have 3 tens and we take away 3 tens, then we're left with no tens. And if we have 7 ones, and you take away 2 ones, you're left with 5 ones. So these are very basic problems. Again, though, do all the problems before you do the work so that the work is actually a check and not helping you get the answers without doing the math. So again, each of these sections ends with 3 word problems. I don't usually do the word problems in these books, but I'm going to do these 2 sets of word problems just because I want to make sure we're getting off on the right foot with how to solve them. So page 34 has 3 problems. Problem number 3, David has 410 U.S. stamps. He has 56 Canadian stamps. Notice when I draw boxes, I'm not worried about proportions, right? We want to know how much he has all together. So if I put the 410 and the 56 together, the question is, how much does he have all together? And clearly that'll be an addition problem. If your student needs to write it down, they certainly can. I would not hinder them from doing mental math if they can look at this and realize that they have 4 hundreds, 6 tens, and 6 ones, and if they can verbalize that to you and show you what it is. We have a balance with Singapore math between encouraging mental math and then sometime wanting them to also show their work. So it doesn't hurt them to write it down. If they have it like this and write the answer down because they've really visualized hundreds, tens, and ones, that makes me happy as well. This is where I'm happy to defer to you as a parent to decide if your student needs to write it down for accuracy or just for getting used to showing the steps. They could write it down horizontally, they could write it down vertically, they could solve it straight from the problem. You can kind of make some decisions based on what you know about your child, how they'll best do with that. Then we have number 4 with Lily and her brother. Lily has 125 stickers. Her brother has 63 more than she does, so the brother is going to be longer. If I draw the line here to where they're equal, the brother has 63 more. What is the question they're asking me? I want to know altogether, how much does the brother have? That's the number I'm looking for. Well, I know the brother has 125 that are the same as Lily. He has 63 more than Lily. I can put that together and say that the brother has 188 stickers. Again, we can write that out horizontally. We can write that out vertically, or we can look at the problem and come up with the answer. I think if they're going to do it mentally, they ought to at least have a drawing. So Mr. Cohen sells 242 books and has 304 books left. And we're trying to find out how many books he has at first. His books are divided into 2 groups. He sells some, and he has some. The total number of books that he had at first will include all those books that he has now and all the books that he sold. So again, I wouldn't want them to look at the problem and write it down without doing anything. If they can look at that and realize this is an addition problem, they could write it out horizontally and come up with 546. They could write it out vertically and come up with 546. Or they could draw a bar graph, I have to admit that's my favorite, and realize that the 2 numbers combine to give you 546. In a word problem, understanding what's going on is so important that drawing something, even just a quick, easy graph, it doesn't have to be a beautiful, lovely graph, just something quick and easy will be helpful to them. Finally, on page 39, the 3 problems at the end of the subtraction. There will come a day in Singapore math when the subtraction exercise doesn't always have only subtraction problems. We're starting out very basic, and we start with number 3 on page 39. A tailor bought 68 buttons. Maybe I'm going to draw my bar graph this way because he's going to stack all those buttons in a one big stack. This is the 68 buttons that he has, and he uses 43 of them. So 43 of them are gone, and we want to know how many he has left. Clearly this is a subtraction problem. I don't even have to rename anything. I had 6 tens and subtract 4 tens. I have 8 ones and subtract 3 ones, and he has 25 buttons remaining after he uses 43 of the 68. Number 4, Morgan saved 276. She saved more than Lily. So here's Morgan's and here's Lily's. And I know that Morgan has 276. I know that if I drew the line to where Lily's and Morgan's were equal, that Morgan had 54 more than Lily. And what's the question they're asking me? The question I'm trying to find for this problem is, how much does Lily have? Well, Lily has the same amount as Morgan does in the orange portion of the graph. And so that's going to be 276 subtract 54. However you do that problem, you're going to end up with a total of $222. I should have drawn it down there, but that's how much Lily has, and that's also how much Morgan has in this portion of her picture, of her graph. Last problem, number 5. Courtney went shopping with $563. She bought a watch and she had some money left. So the number that we're given is 563. That's the starting point. If she buys a watch for $142, that money is gone. Nope, I did it backwards. Always good to pay attention to what exactly the words mean. After she went shopping, she had $142 left. She bought a watch. What we know is that 142 plus that watch amount is going to be 563, or otherwise stated, 563 take away 142 is equal to the amount the watch had. Again, let me point out to you, exercise 8 is how we started out the week, and we did exactly this to understand that these two problems are identical and you could solve it either way. We're not doing anything hard, we're not renaming anything, we just have 421. We need 400s and 2 tens and 1 1, or when you subtract you end up with 400, 2 tens and 1 1. So she must have paid $421 for that watch. And that is the end of the information you need for the week 3 recording. Yeah, and there are no other recordings for this one because all the problems are worked in this recording, so there's not a solutions recording for this week. Thank you very much.